Welcome back to Practical PyTorch. Last time you fed the model with a data loader. Now the real question, is it actually learning? This is validation, overfitting, and evaluation. Train a model and its loss on the training data keeps falling. That looks like success. But a model can score perfectly there by memorizing. It can learn nothing that transfers. The honest test is data the model never trained on. That is a held-out validation split. When training loss falls but validation loss does not, the model is overfitting. It is memorizing, not learning. This video has 4 parts. First, the held-out split. Train to learn, validation to judge. Second, train mode and eval mode, and why we measure with no grad. Third, the two-curve diagnosis, what it means when validation turns back up. And fourth, accuracy, the honest score on held-out data. First, the held-out split, train on one slice and judge on another. We have 440 labeled examples. Take the first 40 to train on. That is the training split. The other 400 are held out. The model never sees them during training. The training split is what the model learns from. The validation split is what you judge it on. The model never updates its weights from validation data. So a good validation score is evidence the model works on data it never trained on. Ask each split for its shape. The training set is 40 by 20. The validation set is 400 by 20. Both carry 20 features per example, only the count differs. There are only 40 training examples. A small set is easy to memorize, so overfitting shows up fast. The 400 held-out examples are the honest exam. Next, 2 switches. A mode switch on the model and a switch that stops the graph. A model has 2 modes. Call model.train to put it in training mode. Call model.eval to put it in evaluation mode. These flip a switch inside layers like dropout and batch norm. Those layers behave differently while training than while being scored. So set the mode before each phase. Train to learn, eval to judge. Forget model.eval and dropout stays on. Then your validation score is measured through noise. The score turns unreliable for models with dropout or batch norm. Always switch to eval mode before you measure. Switch to eval mode first. That sets the layer behavior. Then wrap the measuring in torch.noGrad. Inside it, PyTorch builds no graph. It just computes the validation loss. NoGrad is the tool from the AutoGrad lesson. Evaluation only measures. There is nothing to backpropagate. Skipping the graph saves memory and time. Keep the 2 switches separate. Eval sets layer behavior. NoGrad stops the graph. Each epoch starts the same way. Put the model in train mode. Run the forward pass in the loss. This is cross-entropy on the raw logits, just like the loss lesson taught. No softmax at the output. Then zero the grads, run backward and step the optimizer. These are the 5 steps you already know. This block updates the weights. Now a separate evaluation block. Switch to eval mode. Wrap it in noGrad. Compute the validation loss. This block only reads a number. Record both losses every epoch. That is what draws the 2 curves. Now the heart of the video. 2 loss curves and the moment they split apart. Plot both losses against the epoch. The blue curve is the training loss. It starts high and falls smoothly as the model learns the data it can see. A falling training loss is expected. The model is being pushed to fit exactly this data. On its own, this number tells you nothing about new data. Now add the validation loss in violet. This is the loss on the held-out split. At first it falls right along with training. While both curves fall together, the model is doing better on held-out data. The improvement shows up on data it never trained on. So far, so healthy. Keep training. The blue training loss keeps falling toward the baseline. But the violet validation loss bottoms out and turns back up. That is the warning sign. This widening gap is overfitting. The model gets better on the training set and worse on held-out data. It memorizes more than it generalizes. The green marker sits on the validation minimum at epoch 5. Those are the weights to ship. So here is the rule. Once validation loss turns up while training keeps falling, extra epochs memorize more than they generalize. Ship the weights from the lowest point. Here that is epoch 5. This is not a schematic. It is the measured run. Training falls smoothly toward 0. Validation bottoms at epoch 5 at 0.605. Then it rises to 1.455. The bowl is real. Training reaching near 0 is the tell. It has all but memorized the 40 examples. Weed the two losses side by side. At epoch 0, train is 0.746 and validation is 0.705. They fall together. Validation bottoms at epoch 5 at 0.605. By epoch 8, it is already climbing. In the right column, training keeps dropping to 0, but validation keeps climbing to 1.145, then 1.455. The validation minimum is epoch 5. Every epoch after it is overfitting. Last part. Accuracy, read as the gap between memorized and honest. Accuracy is the share of examples the model labels correctly. argmax picks the highest logit as the prediction. Compare it to the true label. Cast the matches to floats and average. Notice it reads the raw logits directly. The predicted class is just the largest score, so no softmax is needed to decide a label. Accuracy is a plain human number. The share it got right. Score accuracy on both splits at the start and at the end. At epoch 0, both sit near chance. By epoch 40, train accuracy is a perfect 1.00. Validation accuracy is 0.75. That perfect training score is the memorizing, seen from the accuracy side. The model has memorized all 40 examples. 0.75 is its honest score on held-out data it never trained on. A report that quoted the 1 would be quoting the model's memory, not its skill. Let's bring it together. Hold out a validation split. It is data the model never trains on. That is the honest test. To measure, switch to model.eval and wrap it in no-grad. Set the mode, skip the graph. When validation loss turns up while training keeps falling, the model is overfitting. Ship the validation minimum. And remember, a perfect train score can be pure memory. The validation score is the number that holds up on held-out data. One check before we go. Validation loss falls, bottoms out, then turns back up. Which epoch's weights do you ship? Pause and predict. The answer is epoch 5, the validation minimum. Validation loss is lowest there, at 0.605. Every epoch after memorizes more while the held-out loss climbs. Ship epoch 5's weights, not the last ones. Save a copy there, that is early stopping. You can now tell learning from memorizing. But what about when the run does not get that far? When it throws? The next lesson is debugging, shapes, devices, and gradients. The 3 error messages behind most PyTorch pain, and how to read each one bottom up and fix it in one line. See you there.